All right, so we're talking about acidity, basicity of solutions. And so if you think about kind of just common day life, what measurement do we use to quantify how acidic or basic is? That's going to be pH, right? You've probably heard the term pH before. If you have a pool, you have to keep it at the right pH. If you get like some pet fish, it has to be at the right pH. You can talk about the pH of, all kinds of different things. But, what does it actually mean? So let's take a look at what it means. So pH is equal to the negative log of the concentration of H plus, right? And so this P, we're going to see this P a lot. What P means is take the negative log of something, right? So P means take the negative log of something. In this case, since we're talking about pH, we're talking about the concentration of H plus. So you can see when you're talking about the pH of something, what you're really talking about is how much H plus do I have in there. And so while we commonly use pH, there's actually another term, POH. And so this one's not nearly as commonly used, but it still means negative log from the P. And in this case, we're talking about OH, so we're talking about the concentration of hydroxide. And we'll talk about the relationship between pH and POH in a little bit. But first, let's just talk very briefly about logs. So what does log mean? So for example, log of X is equal to B. What does that mean? The first thing we have to know is that when we just say the log of something, that there's actually a 10 down here. There's a 10 down here. This is implied. So unless you say log base 2 or whatever, if you just say log, that means that it's 10. And if you reorganize this equation, basically what you can say is 10 to the b is equal to x. And so when you find the log of some number, basically you're just kind of saying how big it is, how big that number is. So for example, the log of 100,000, it's really just about how many decimal places you move over, right? So we can move over 1, 2, 3, 4, 5 decimal places to get kind of just one number in our ones place. And so the log of here is going to be equal to 5. And then same thing when you talk about very small numbers, so log of 0.00001. If we want to get just one number in our ones place, we would move this decimal spot 1, 2, 3, 4, 5 places over. And so you'd get a -5 because we're moving to the decimal or the decimal to the right place. So it's just a way of quantifying big numbers, right? Instead of saying 100,000, we can just say 5 type of thing. You don't have to have a great understanding of logs because you do have a calculator, obviously, but it does kind of help if you understand how logarithms work. And we'll talk about them a bit more later on. So let's go back to neutral water. Right, the concentration of H plus in neutral water we saw last time is equal to the concentration of hydroxide, and them multiplied by each other has to be 1 times 10 to the -14. So in neutral water, they're both 1 times 10 to the -7, right? And now we just learned that pH is equal to the negative log of H plus. And so when we're talking about neutral water, we can take this number, plug it into here, right? What you'll get is the pH is equal to the negative log of 1.0 times 10 to the -7, right? And so this point we have a small number, something like this right here, right? Except we're moving our decimal spot 7 places over. So the log of that is going to be -7. And then we have this negative component here. So that's going to cancel out with one another. And so the pH is 7. So a decent number of you probably know that neutral water or anything that's, neutral has a pH of 7. So this is why, right? Because in neutral water, the concentration of H plus is 1 times 10 to the -7. And because pH is negative log, if you take the negative log of that concentration, you get 7. So that's kind of why 7 is not really chosen as, the neutral thing, but that's what it is in real life. That's what it's measured, right? So we said in acidic solutions, right? The concentration of H plus is going to be greater than the concentration of hydroxide. And so the concentration of H plus is going to be something like 1.0 times 10 to the negative 7, right? So let's take a look at some pH values here. So if you plug that in, obviously that's 7, right? So, right, 1 times 10 to the negative 7, the negative log of that is 7, so that's neutral. But if we want to get greater than 1 times 10 to the negative 7, we could say maybe 1.0 times 10 to the negative 6, or maybe 1.0 times 10 to the negative 5. And if you take the negative log of these numbers, the numbers you'll get are 6 and 5. So we can see as our concentration of H plus increases, our pH decreases, right? So that's why when something is acidic, it has a low pH. And then vice versa in basic solutions, the concentration of H plus is less than that of the hydroxide, so it's less than 1.0 times 10 to the negative 7. And so maybe 1.0 times 10 to the negative 8 or 1.0 times 10 to the negative 9. And so if you take the negative log of these, you'll get 8 and 9. So when we get to a more basic solution, our pH goes up. So just to kind of summarize, acidic is pH is less than 7. Neutral is pH is equal to 7. And then basic is pH is greater than 7, right? And then remember, as the concentration of H plus goes up, the pH goes down. And now you know why, because it's negative, it's this negative log base.